Good morning, students. Today we are going to discuss about question bank of mechanical properties of fluids. The first question is the pressure at the bottom of a tank containing a liquid does not depend on. Pressure at the bottom of the tank is nothing but absolute equal to P atmospheric pressure plus rho G H. It depends on density, that means the nature of the liquid. It depends on acceleration due to gravity. It depends on H. It does not depend on area. So answer A is the answer. Option A is the answer. Next, specific gravity of a body is numerically equal to, specific gravity is equal to density of the object divided by density of water. This is nothing but relative density, and it has no units because it is the ratio of two same physical quantities. Answer A. And the surface of water in contact with glass wall is, the surface of water in contact with glass wall is, it is looking like a cave. It is looking like a shape of cave, so we call it as concave. Answer is concave. Okay, next. Containers A, B, C are filled with water as shown in the figure. What is the relation between pressures at 1, 2, 3? All these 3 points are at same level from the top. Same level from the top. So depth H is same for all the three. So we know that absolute pressure equal to atmospheric pressure plus rho g h. As H is same, pressure is also same. So P1 equal to P2 equal to P3, and their ratios are in the order of 1:1:1. So option A is the answer. Okay, next. Pascal's law is valid only for water, metals, fluids, gases. It is valid for fluids. We know already. What is Pascal's law? For every action, there is an equal and opposite reaction. No, this is not answer. Force is the time rate of change of momentum. It is not the correct answer. For an ideal gas, the pressure is directly proportional to temperature and constant volume and mass. Not. A pressure change at any point in the fluid is transmitted throughout the fluid such that the same change occurs everywhere. This is the correct answer. Option D is correct. And a force is applied on a uniform rod of cross sectional area A, and a force F. Force F is applied on a uniform rod of cross sectional area 3A. Now in the case is cross sectional area is increased from A to 3A. What is the relation between force F and F dash? If the pressure on both is same, pressure is same on both. So pressure is same. So in first case, if cross sectional area is A, the amount of force acting on it is nothing but F. So we know that force equal to pressure into area. In the second case, the force is F dash if cross sectional area is 3A. So F dash is equal to, pressure is same, it told, as given, into 3 into A. So I am taking the ratio of F and F dash. So this P and P get cancelled. A and A get cancels. We will get F by F dash is equal to 1 by 3. This is the answer for this question. So option C is correct answer. Now the neck and bottom of the bottle of a bottle are 3 centimeters and 15 centimeters. Neck and bottom, like this. Okay, neck is 3 centimeters and bottom is 15 centimeters. If the cork is pressed with a force of 12 newtons, cork is pressed with a force of 12 newtons. If F1 equal to 12 newtons, the force exerted on the bottom of the bottle is, what is the force at the larger cross sectional area? We know that F2 is equal to A2 by A1 into F1 from Pascal's law, application of Pascal's law. So here F2 is equal to A2 is nothing but pi R2 square by pi R1 square into F1. So here R2 square is nothing but 3 square, sorry, it is 15 square divided by 9 square, pi and pi get cancelled. R2 square is 15 square, R1 square is 9 square, into F1 is how much? F1 is given as 12 newtons. 12 newtons. 3 square, 9 square, not 9 square, it is 3 square. So 15 square is nothing but what? 225. F2 equal to 225 by 9 into 12. So 9 1 ja, 9 25 ja. So 25 into 12 is nothing but 300 newtons. Answer is 300 newtons. Okay, next. See here, I need to, I had to mention here the density of mercury. Density of mercury. I have forgotten to mention here. Density of mercury is 13.6 gram per cc. 13.6 gram per cc. Okay, now see here, a liquid X of density 3.36 gram per centimeter cube. Liquid X density is 3.36. Is poured in a U tube which contains, this U tube contains mercury. So this is all mercury. Okay. Now another liquid Y is poured in left arm with height of 8 centimeters. So this is 8 centimeters. Okay, and upper levels of X and Y are same. This level and this level are same. Both are at same level. But bottom levels are not same. This bottom level is at a depth of 10 centimeters from upper level, but this bottom level is at a depth of 8 centimeters only. But we know that pressure is same at both 2 points. So pressure at this point must be equal. So here up to 10 centimeters it is being filled with some liquid X. Up to 8 centimeters it is being filled with unknown liquid of density Y, and 2 centimeters is being filled with mercury. This 2 centimeters is being filled with mercury. So 8 centimeters is unknown liquid of density Y, and 2 centimeters with mercury. So here pressure at this point P1 must be equal to pressure at this point P2. So here I am writing an expression for P1. P1 is nothing but what? Atmospheric pressure plus rho GH. Rho density of Y. First 8 centimeters is density of Y material into G, height of the Y, plus another 2 centimeters is being filled with mercury here. So we need to take density of mercury and acceleration due to gravity into H of the mercury. Okay, so I am mentioning everything here. See here, density of Y is unknown. Okay, P atmospheric value is known, G value is known, HY is nothing but here, HY is equal to 8 centimeters. Okay, and density of mercury is known, density of mercury is equal to how much? 13.6 gram per cc. All the quantities are in CGS system, so no worries. And G value is G, and H, height of the mercury, is nothing but how much? 2 centimeters. We need to substitute these values later. Now, so pressure at point 2. Write down an equation for pressure at point 2 here. So pressure at point 2 is equal to P atmosphere plus density of, this 10 centimeters is being filled with what? Density of the material X. So density of the material X, rho G H, height of X. So here rho of X equal to as given 3.36, and G value is known, H of X is nothing but 10. Okay, everything is in CGS system, nothing to worry. So this he has given Density of X equal to how much? 3.36 gram per cc, and height of X is equal to 10 centimeters. Okay, now equate pressure P1 with P2 because both are at same level. Now I am equating P1 and P2 here. So P1 is equal to P2. That means P1 is equal to atmospheric pressure plus rho y g h y plus rho of mercury g h, height of the mercury, is equal to what? Atmospheric pressure plus rho of x g hx. Okay, see here, atmospheric pressure, pressure get cancels, right? Now rho y unknown, g hy equal to how much? 8 centimeters, and rho density of mercury is known, g value is known, okay, h value is known. So I am substituting rho y into g into hy is 8 centimeters, okay, plus rho of hg is nothing but 13.6 into g into height of the mercury on the left side column is 2 centimeters is equal to rho x is nothing but how much? 3.36 into g into height of right side column is 10. So here, right, 13.6 into 2 is nothing but 27.2. I hope it is right. 13 to the 26, yes, 27.2, right. So 8g rho y is equal to 3.36 into 10 is nothing but 33.6 into g minus 13.6 into 2 is nothing but 27.2 g. Okay, so you will get 33 minus 27 is nothing but 6. 0.6 minus 0.2 is nothing but 0.4, so 6.4 g. So 8 g rho y, g and g cancels, so therefore density of y material equal to 6.4 by 8. By solving this, you will get the answer as 0.8 gram per cc. Next, 10th question. A metal plate of area is given. Area of the metal plate is equal to how much? 10 centimeter square on a layer of oil 6 centimeter thickness. A tangential force of 10 power minus 2 is applied on it to move it with constant velocity of 6 meter per second. Okay, and L equal to 6 mm, and here velocity v is equal to 6 centimeter per second. Velocity v equal to the coefficient of viscosity is, we know that coefficient of viscosity equal to F into L by A into V. Okay, so he has given force is given, yes, force is given, and length is given, isn't it right? Area is given, and also V, velocity is given. So you can find out eta value, coefficient of viscosity, that is, it will come out as 0.1 poise, right? So next, 11th question. In a hydraulic jack as shown, mass of the car is 800 kg. A1 is given, A2 is given. The minimum force required to lift the car is, F1 is how much? F2 is given, F2 is equal to 800 kg into 9.8 newtons. Okay, so you know the value F1 by A1 from Pascal's law, F1 by A1 equal to F2 by A2. Therefore, he asked about F1, F1 equal to A1 by A2 into F2. So here A1 is given, A1 is how much? 10 centimeter square. 10 centimeter square, and A2 is 10 meter square. Convert this centimeter square into meter square. 10 into 10 to the power of minus 4 meter square divided by A2 is nothing but 10 meter square. Write it directly into F2. F2 value is how much? 800 into 9.8. By solving this, you will get the answer for F1. Okay, a barometer kept in an elevator reads 76 centimeters when it is at rest. Barometer reads the height of 76 centimeters of mercury when the lift is at rest. When the lift is at rest. Okay, when lift is at rest, h is equal to 76 centimeters of hg. And if the elevator goes up, how many forces are acting on elevator here? One is upward force, tension force in the cable. Another one is downward gravitational force. And he is saying that the elevator is accelerating upwards, goes off with some acceleration. In this case, acceleration is there. So, from Newton's second law of motion, sigma F equal to m into A. Here, sigma F is nothing but T plus sigma, summation of forces. Upward force is nothing but tension force plus downward force is nothing but mg here is equal to m into A. Therefore, new tension is equal to m into g plus ma. Okay, so m into g plus a. Now, new acceleration g dash equal to g plus a. So, acceleration is increasing in this case. Okay, now the reading of the barometer when the lift is going upside with some acceleration. Okay, when the lift is going upside, that means we get rho g h value. Height will be, see here, g dash, rho g dash h. Total should be, the pressure should be constant. Pressure of the atmosphere is 76 centimeters of hg, but it is the barometer is kept inside the lift which is moving with acceleration a, so that now new acceleration due to gravity is g plus a. So as g dash increases, h should be decreases because rho gh value, total value must be constant. So in order to get the constant value, as g dash increases, h should decrease. H should be less than 76 centimeters of hg. So correct answer is this one. See, figure shows two containers P and Q with the same base area A and each filled up to same height with same liquid. Select the correct answer. As the heights are same in both, so we know that absolute pressure is equal to atmospheric pressure plus rho gh. Atmospheric pressure is same for both and same liquid, so density is same, g value is same, so h is same, pressures also same. Therefore, px is equal to py. So don't care about shape of the containers. Just take care of h, whether they are same or not. Just look at the height. Now, moving to next question. Plants get water through the roots because of capillarity. This is a direct question. And next, the velocity up to which the flow of a liquid remains streamlined and above which it becomes turbulent is called critical velocity. Option A. Next, one of the major factors that determines the laminar or turbulent nature of the flow of the fluid. If the flow speed is less, the nature of the fluid flow is streamlined, and if the speed of the fluid is more, then we can say that the flow is turbulent. So velocity of the fluid, it depends on velocity of the fluid. Next, a body is falling freely in a viscous fluid. Finally, it falls with constant velocity. Why? I have discussed already. When raindrop is falling from the clouds, whenever it is moving through viscous fluid, consider I am taking viscous fluid is nothing but, let us consider this is all atmosphere. Whenever the raindrop is falling like this, so atmosphere exerts an upward force on it. That upward force is nothing but viscous force. Another force is nothing but, viscous force is nothing but frictional force exerted by air fluid on the raindrop, upward force. And also buoyancy force is there. Buoyancy force is nothing but weight of the displaced fluid. We know the definition of weight of weight of buoyancy force equal to weight of displaced fluid. We know the Archimedes principle. When an object is immersed in a liquid, the fluid exerts an upward force on the object. That upward force we call it as buoyancy force, which is equal to weight of the displaced fluid. And another force that is acting on the raindrop whenever it is falling is nothing but weight, m into g. When these two upward forces, sum of these two upward forces exactly matches with mg, the net force is equal to 0. If net force equal to 0, acceleration equal to 0. If acceleration equal to 0, velocity of raindrop is constant. So after reaching certain position, the raindrop will move with constant velocity thereafter. That constant velocity we call it as terminal velocity. Okay, so answer is A. Next, hydraulic brakes works on the basis of Pascal's law. Direct question. To which type of fluid is Bernoulli's theorem strictly applicable? Bernoulli's theorem is applicable for non-viscous fluid, isotropic fluid, steady nature, the fluid which is having steady nature, irrotational, and another property is nothing but incompressible. If a fluid having these properties, non-viscous, isotropic, steady, irrotational, incompressible, such a fluid we call it as ideal fluid. We discussed already while discussing about the Bernoulli's theorem. Bernoulli's theorem is applicable only to ideal fluid. Ideal fluid is nothing but it should be non-viscous, isotropic, steady, irrotational, incompressible. But here it is saying viscous fluid, so this is not correct answer. Anisotropic, it is not correct answer. Compressible, it is also not correct. None of the above is the answer for this question. Next, Bernoulli's theorem is based on the principle of conservation of energy. Okay. Next, 1 atmosphere is equal to 1.013 into 10 to the power of 5 pascals. We know it. A pressure equivalent to 1 mm of Hg, 1 mm of Hg is equal to 1 tar. Basic definition. So, a tar is the answer. So, 1 mm of Hg is equal to 1 tar. So, we know 1 atmospheric pressure is equal to 76 centimeters of Hg or 760 millimeters of mercury. Okay, so we know that. So 1 atmospheric pressure is equal to 760. 760 into 1 mm of Hg is nothing but what? 1 tar. So 1 tar. Right? So now 1 atmosphere is nothing but 1.013 into 10 to the power of 5 pascals is equal to 760 into 1 tar. Therefore, 1 tar is equal to right 1.013 into 10 to the power of 5 pascals divided by, when this comes to left side, it will be under denominator. By solving this, you will get 1 tar is equal to 133 pascals or 133 Newton per meter square. So 133 pascals, and pascals are equivalent to Newton per meter square, 133 Newton per meter square. So both A and B are the answers. Now I am going to discuss about next question. That is question number 24. Sorry. Water stands 12 meters. Yes, water stands 12 meters deep in a storage tank whose top is open to the atmosphere. What are the absolute and gauge pressure? Absolute pressure is nothing but, we know absolute pressure equal to atmospheric pressure plus rho GH. So we know atmospheric pressure value 1.013 into 10 to the power of 5 pascals. He has given water density is 1000 kg per meter cube, and G value is 9.8 meter per second square, and H, depth H equal to 12 meters. So substitute in it, you will get the absolute pressure. And gauge pressure is nothing but, gauge pressure is, it is the difference of absolute pressure and atmospheric pressure. So gauge pressure is nothing but simply rho gh. Density is given, g value is given, h is given as 12 meters. So by substituting the values, you will get the answer for question number 24. Right. Next, 25. In the case of 25, for incompressible oil of density, rho is equal to 850 kg per meter cube is pumped through a cylindrical pipe at a rate of 9.5 liters per second. So he has given volume flow rate. We know volume flow rate. Volume flow rate is nothing but, from equation of continuity, volume flow rate is equal to A into V. Isn't it right? A into V is called as volume flow rate. I have told you already in the classroom. So why we call it as volume flow rate? Let us see here once again. Area units are meters square and velocity units are nothing but meter per second. So meter square into meter is nothing but meter cube per second. So meter cube is nothing but units of volume divided by second is nothing but units of time. Volume per unit time is called as volume flow rate. Therefore, area into velocity is equal to, he has given 9.5 liters per second. He has given volume flow rate. So, converted into SI system of units. 9.5 into 1 liter is nothing but 10 power minus 3 meter cube divided by second. So now we got the value of A into V. Now A value is nothing but the first section of the pipe has a diameter of 8 centimeters. So area is nothing but pi. Diameter is 8 centimeters. So radius equal to 4 centimeters. Pi r square, that is nothing but 0.04 whole square into velocity V is equal to 9.5 into 10 to the power of minus 3. Right. So now unknown thing is only velocity. So you can find out the speed of the oil by using this relation. Next, question number 26. Water is flowing in a pipe with a varying cross-sectional area, and at all points the water completely fills the pipe. At point 1, the cross-sectional area of the pipe is 0.07 meters square. Okay, and the fluid velocity is, yes, given, A1 is given, V1 is given. What is the fluid velocity at a point where cross-sectional area of the pipe is A2? So A2 is also given. So what is asked here? He asked about fluid velocity at the second point. So what is V2? What is V2? So here A1 is given, V1 is given, A2 is given, asking for V2. From equation of continuity, we use continuity equation. What is continuity equation? A1 V1 is equal to A2 V2. A1 is known, V1 is known, A2 is known. The unknown thing is only A2. We can find out the answer for V2. Next, question number 27. A sealed tank containing seawater to a height of 11 meters also contains air above the water at a gauge pressure of 3 atmosphere. Water flows out from the bottom through a small hole. How fast is the water moving? This is the application of Torricelli's theorem. Okay, speed of efflux. You have the direct relation to find out this answer. We know the direct equation of speed of efflux is, we have derived already in the classroom. This is under root of 2gh plus 2 into p minus p atmosphere by rho. So 2 is known, g is known, h value is 11 meters, 2 is a number, p minus p atmosphere is nothing but gauge pressure. Has given gauge pressure as 3 atmospheres. So convert into gauge pressure equal to gauge pressure 3 atmosphere. 3 into 1 atmosphere is nothing but 1.013 into 10 to the power of 5 pascals. Convert it into SI system of units and substitute here. And rho value is nothing but density of the seawater is 1000 kg per meter cube. So you can find out the answer for question number 27 directly using this relation. Next, the air of velocity 15 meter per second. So here he has given V1 is equal to V1 is equal to 15 meter per second. Question number 28. Yes, 15 meter per second. And also a density is given. Density is equal to 1.3 kg per meter cube. Entering the Venturi meter from the left. The radius of the wide part of the tube is 1 centimeter. So wide part area is nothing but capital A. So we know pi r square, pi into, here radius is 1 centimeter square, that is 0.01 whole square. So you will get the answer for A, capital A. And also the radius of the thin part of the tube is small a is equal to 0.5 centimeters, that is nothing but pi into 0.05 whole square meter square. So you will get the answer for small a also. And here the tube of shape U connecting wide and thin part of the main tube is filled with U-shaped tube is being filled with mercury of density rho m equal to, here density of mercury equal to 13,600 kg per meter cube, that is inside the U-shaped tube. Okay, determine the height difference that stabilizes between the surfaces of the mercury in U tube. So we know that density rho m g h is equal to half density of the water or the density of the fluid that is flowing in the Venturi meter is rho. Rho m is nothing but density of the fluid that is inside the U-shaped tube, that is mercury. That density is 13,600 kg per meter cube. So rho m g h equal to half rho v1 square into capital A square by small a square minus 1. So here we know this value is known, g value is known, half is half, rho is known. He has given rho value as 1.3 kg per meter cube, 1.3 kg per meter cube. And V1 is given as 15 meter per second. Capital A, we found capital A value and small a value as well, and 1 is 1. So unknown thing is h. You can find out the h from using this relation. So, okay, the viscosity of liquids with increase in temperature. So we have discussed already. In case of liquids, there are cohesive forces are there. Cohesive forces are there. As temperature increases, cohesive forces decreases. Cohesive nature decreases. As temperature increases, cohesive nature decreases. So viscosity decreases. Viscosity decreases. In the case of the viscosity of liquids, no, the question is repeated again. This is not liquid, it should be gases. The viscosity of gases with increase in temperature. In case of gas molecules, consider there are large number of gas molecules inside the volume of the vessel. Now, if I supply heat energy to it, that means if I increase the temperature, the collision rate increases, the speed of the molecules increases, so collision rate increases. So as the molecules collide frequently in this case, so motion of the molecules will be get opposed in each collision. So opposing nature is increasing. The opposing nature is called as the viscosity. So viscosity of gases increases as temperature increases. Okay. Now the ratio of internal force to viscous force is called Reynolds number. It is direct question. And a body of density D will be immersed in a fluid of density rho if density of fluid is more than density of the object, then object will be floating. What is the pressure on a swimmer 20 meters below the surface of the lake? Pressure, absolute pressure is equal to atmospheric pressure plus rho gh. Atmospheric pressure we know 1.013 into 10 to the power of 5 pascals. Swimmer, he has given density of water, g value, h value is 20. By substituting the values, you will get the answer. So next, at a depth of 2000 meter in an ocean, find the gauge pressure. Gauge pressure is nothing but rho gh. So gauge pressure is equal to rho gh. Rho value is given 1030 and g value is a 9.8 and h value is also given 2000 meters. So you can find out the answer for this question. Right. In a car lift, compressed air exert a force F1 on a small piston having the radius of 10 centimeters. So we can find out area A1. And also this pressure is transmitted to a second piston of radius. He has given second piston of radius also, so we can find out A2 value. If the mass of the car to be lifted is how much? 1500 kg. So F2 is given, F2 equal to m into g, that is 1500 into 9.8 newtons. We know this also. What is the necessary pressure to accomplish the task? Necessary pressure asked. So pressure at first point equal to pressure at second point, but he has not given F1. So pressures are remain same from Pascal's law. Therefore, if you find out P2, that is also equal to P1. P2 is nothing but F2 by A2. He has given F2 value and also A2 value. So you can find out pressure P2 here by using this relation. Okay, which of the following gives Bernoulli's principle? Right, this is half mv square kinetic energy. We know that Bernoulli's principle is nothing but pressure plus half rho v square. We know this relation, but we haven't seen this relation. Rho gh equal to constant. We know this one. See one thing, multiply with the volume. So pressure into V plus half density into volume into V square plus density into volume into G into H. I might multiplied with just volume V equal to constant into V is nothing but again we get constant value. So PV plus half density into volume is nothing but mass of mv square plus density into volume is nothing but mass mgh. This is also constant. So this is another form of Bernoulli's equation. Now the efflux speed from a hole below the water level in a vessel is 9.8. Efflux speed is given. The distance of the hole from surface of the water, h value is asked. So here efflux speed is equal to under root of 2gh. Find out the expression for h value using this relation. Equation of continuity for incompressible fluids is consequence of conservation of mass. Okay. Next, a fully loaded aircraft has a mass of 4 into 10 to the power of 5 kg and its wing area is, mass is given, wing area is given. Find the pressure difference. We know the pressure difference formula equal to half rho into V2 square minus V1 square, or the pressure difference is equal to pressure equal to force per unit area. He has given force, that is m into g. M value is given, multiply it with g so that you will get the force, and wing area is also given. So wing area is how much? 200 meter square. So you can find out pressure difference by using this relation. So don't use this. Next, and laminar flow is, laminar flow means the velocity at different points in the fluid may have different magnitudes but their directions are parallel. This is called as the laminar flow.